So for the next 20 minutes, I'm going to take you on a journey through the Azure Cosmos DB. And I really want to cover two items. The first is this concept of a NoSQL database so that we can compare and contrast. I'm sure a lot of people tend to be more familiar with relational databases than NoSQL. So I'll talk about that. And then I'll cover Azure Cosmos DB, which is our platform for NoSQL within Azure. So my name is Jeremy Likness. I'm a cloud developer advocate here at Microsoft. And in my 20 years of professional development, I've never heard this phrase before, right? It's how we've always done it. So I want to level set a little bit. Now, it'd be an oversimplification if I said that the only reason we have relational databases is because of storage. But that was a huge driver 3 decades ago, and I'm showing my age a little bit, but that's all right. 3 decades ago, storage was exponentially more expensive. And the database optimizations were all about having the least space used as possible. So that led to charts like this, where we have relationships and we're storing data, referring to it by IDs, and everything that comes with that. But it creates this interesting paradigm, right? So you have the person on the team who understands how to store data in a normalized database. And then you have the development team that's usually working with some sort of domain-driven model, right? Or object-oriented development. So what do we need in between? Anyone guess what the next object I'll throw up is? ORM. Perfect. Could you please? No. So we've got this ORM. And ORM's not a bad thing. I'm not here to tell you that SQL is a bad thing or that ORMs are a bad thing. In fact, a lot of companies will drive their database from the ORM out, right? So the ORM drives the data side, it drives the object side. But I imagine some of you have been on those projects too where the ORM adds a lot of complexity. So you have to make one small schema change and you're touching it in 15 different places. You have to have a window to roll it out. You have to back up the database in case you need to roll back. And it can create some pain points. So has anyone here ever found themselves creating a table like this? That has column names and integer and string values. So you're basically trying to just store random metadata. Or maybe you've serialized objects and stored them in a huge string field, right? Or maybe you actually use the XML and JSON field types. Well, I'm going to say if you've been doing this in your SQL database, there might be a better approach, a different approach for that data. Now, it's a common misconception that NoSQL means NoSQL is allowed. It's really not only SQL. And the idea is that you can have multiple solutions depending on the type of data that you're dealing with. Now, there are a ton of flavors of NoSQL, but the four most common are the ones I'm listing here: key value, column, document, and graph. So key value store is pretty straightforward. It's a persistent dictionary. And it's highly optimized for when you know the key and you just want to look up the value. So a great example would be a user logging into a website. You've got their user information, you want to pull their preferences out. A key value store is the perfect way to do that. Another example is something I run in production, which is a link shortening tool. And I have the short link that maps to the long link. I look it up, redirect, and it happens quickly. The other type of NoSQL database is a column store. So you can have data organized in what we're used to as rows, but conceptually it's organized in this database as columns. And this does several things. First off, it's highly optimized to query across specific columns in my data set. The second thing is if I'm projecting data, so if I have really large documents and I'm only pulling back a few columns, I can retrieve those columns quickly with this type of approach. The third one's document. I'm going to show you some more complex documents, but it's literally taking an object, storing it in the database. It can be a complex object. It can have arrays and nested objects within it, and we'll see examples of that. And then finally, there's the concept of a graph database. And a graph database is concerned with relationships. So here I've got vertex or nodes in my graph that are airports. And I might have longitude, latitude, name of the airport. And then I have edges, which are connections between airports. And those can have information associated with those as well. So there's a ton of advantages when you move over to the NoSQL world. Probably one of the biggest one is that every document is independent. This means we're not locked into a schema. If we change the schema, we're not going through a huge migration. That does not mean that there's not indexing support, however. So all of the major document database providers will index over fields, sometimes automatically. Sometimes you provide hints and inform the engine how you want to index. But that's existent, and if it doesn't have a property, there's just no index for that property on that document. It's very straightforward to manipulate documents, bring them in and out, and I call them all JSON ready because most return it in a JSON format. So I'm not serializing to a class, then sending it to a middleware, then translating it, then sending it over the wire, and then picking it up and translating it. I can bring it directly out. Now, these engines are designed specifically to handle replicated data sets that are terabytes to petabytes in size. So very large, very fast queries over that volume of data. I call them version proof because as your schema changes, you simply add new documents. You're not going through a migration. And then finally, ORM free, which again, you can use ORMs with certain document databases, but because you're typically taking your business object and just storing it to the database, you eliminate the need to have that extra step in the middle. The driver handles it for you. So Cosmos DB is our NoSQL platform, and it's a fully managed platform. I'm going to talk a little bit about what that means. Now, it covers all 4 of the common NoSQL types, and there's a combination of what I'll call proprietary APIs that we've developed. For example, the SQL API allows me to store document data, but use a SQL syntax to query it. So I can use the same syntax I'm used to from my relational background. The existing APIs like MongoDB and Cassandra really facilitate 2 scenarios. One is migrating existing databases onto the platform, and 2 is leveraging existing skill sets. So if I know how to write code against the Mongo database, I can write code against Cosmos DB. It's just a different connection string. And that's the way it works. Now this provides turnkey global distribution. And what do I mean by turnkey? This is a database that I've set up that I've imported the USDA nutrient database. So I have nutrition information. But if we look at this and I scroll down, you're going to see that I actually loaded the data in on the East Coast and I've replicated to the West Coast. And if I wanted to replicate data to another area, I'll come on this tab inside the portal, and you can see all the different regions that I can light up. And I literally just, let's say we wanted to go to South Central. We would click on that. That region becomes available. We click Save, and it'll automatically start replicating out. Just as easy as that. And that's all managed for me through Cosmos DB. Let's go ahead and say discard edits. Come back here. So the next thing to talk about is this elastic scale out of storage and throughput. So Cosmos DB is a unique model that I'll dive into in a second, that you provision the throughput you need and pay for that up front, and then Cosmos DB guarantees it'll meet that demand. So if you have just terabytes or gigabytes or megabytes, you can move that throttle and guarantee that throughput based on how much usage your application gets. Now, it transparently manages partitions, so you indicate how data can be sharded and optimized as far as physically replicated. You define that up front and say, for example, in my airport example, maybe my airport is the partition. Cosmos DB automatically manages replicating those partitions for you, so it all happens transparently. We have things like automatic document expiration. So let's say I'm tracking someone's web session, and I want that to expire, and I don't want to have to write my own service to do that. I can put a time to live on a document, and it automatically expires out of the database. And then we've got, I talked a little bit about throughput. I'm going to touch on that in a second, but this approach allows Cosmos DB to provide these service level agreements. Low latency at the 99th percentile, high availability, guaranteed throughput, and guaranteed consistency levels. Now, this is a 20-minute talk, so I can't get into consistency levels, but at a very high level, you've got different dials that you can work with in distributed systems: capacity, availability, something called partition tolerance. What's unique about Cosmos DB is it lets you set the level of trade-off that you want depending on the demands for your application. A lot of models either are strong consistency or eventual. There's multiple levels depending on what you need, and you can dive into that more through the documentation. So just talking about this guaranteed throughput, has anyone here heard of request unit and kind of scratch your head? what is a request unit? So it's really just a normalized way of saying this is what it takes to perform an operation. So this is the memory, the CPU, and the I/O that it takes for an operation. So you can imagine that a simple get operation is only going to take a couple request units, maybe even one, whereas a more complex query can take multiples. So the nice thing with Cosmos DB, though, is there is a calculator that allows you to estimate what your request units will be. You can upload documents and indicate reads and writes. But it also gives you information back. So if you exceed your provision throughput, you get information about how long to wait to retry an operation, as well as what you can re-provision your throughput to in order to meet the demand. So the engine provides you all of that feedback. So having said that, I want to jump into these multiple interfaces we talked about. So these are the 5 current supported interfaces. We have the SQL, we have Table API, which is the key value store, MongoDB, which is document, Cassandra, which is column, and Gremlin, which is a graph. And I'm going to show you examples of a few of those. The way Cosmos DB pulls this off is it internally stores data in a special format called ARS. And that format is highly optimized. All the partitioning, all the replication, everything happens with this internal storage format. And then it uses something called projection to project concepts onto the APIs. So for example, I have a container, which is a list of entities that I'm storing. It can be stored procedures, it can be triggers, it can be user-defined functions. And then that gets projected based on which direction I'm going. Let's try the other way. Are we going backwards or are we going forwards? All right, let's try this again. Forward in time, forward. I don't know what's happening here, but you're going to see the fastest animations known to mankind. All right, here we go. Now we're projecting. Great, we made it. So MongoDB collection, table storage table, Gremlin, which is a graph, and the same thing when you look at the individual items. You get a document, you get a key value store, or you'll get a vertex or an edge if you're dealing with a graph. So having shown you that, first example I want to jump into live is the Usda Database. So what I've done is taken 12 relational tables, collapsed them into 3 collections, which is what we call it. Now, it could have been 1 collection, but I wanted to keep the example simple, and you'll get a link to the example afterwards. But what this looks like inside of the database is this one that I'm on right here, and you can see the collections that I have listed here: food groups, nutrient definition, and food items. So if I drill into food items, for example, this is going to give me a MongoDB API that I can use to parse through my data. So what I'm going to do is just click on one of these documents, and then we'll take a look at the document. You can see it happens to be dairy and egg products. You can see there's different amounts of food and whatever. And I also want to just show you this complex object. So there's a nutrient doc property that has a nutrients property that has water and protein and fat, etc. So that's something that I can navigate through to on my document. What I can do then is create a query in MongoDB, and the way MongoDB styles queries is through JSON objects. So what I'm going to say is, let's look for nutrient doc, nutrients, protein count, amount, and I want to find food items that are high in protein by weight. So what has a really high density of protein. So I'm going to say greater than 80. And the amount is the amount of grams in 100 grams of the food item. So if we do this and we execute the query, it's going to parse that MongoDB query, go out to the database, and literally take the automated index over that field, slow down over conference Wi-Fi, bounce around a couple access points, come in through the router, and we get 7 results, which also happens to start with dairy and egg products because eggs have a lot of protein. So that's showing you through the portal, but I also want to show you an application running off Cosmos DB. So this is what I'm using to connect, and the only thing I want you to take from this slide is it's a MongoDB driver. It's part of the MongoDB SDK. Mongo has no idea it's talking to Cosmos DB. That's just an endpoint that I'm configuring here. Then if we look at my class, this should be pretty familiar. I've got a plain old C# object. This could be a JavaScript object. It could be a Java object. And I've just annotated it with some extensions from the MongoDB SDK. So it knows what the ID is, it's ignoring some properties, etc. That's all part of the base driver. And then for my code, for example, if I want to do a filter, I can use things like link queries. If you're in C#, I can use Lambda expressions. But I can use a fluent filter language. There's nothing special I'm doing here, and this gets projected out to the database as a query. So what does that look like actually running? So I've got an example here, and I'm just going to pause and take credit. I did do all the UI design for this myself. Thank you very much. And what I'm going to do is just select a food group. We'll do dairy and egg products, and we'll search over thousands of items to find what has scrambled inside the text. And boom, we get egg. So I'll click on egg, and there we get the nutrient information. So, and that's not on any special Wi-Fi. This is literally over the same Wi-Fi you're using. I happen to follow a 100% plant-based diet. So what I might want to do is look at nut and seed products and find out which ones are really high in calcium, because calcium is important to get. So if I do this calcium, nut, and seed products, get top foods, what it's just done is it's sorted the top 100 foods by weight so that the food at top has the most calcium content, food at the bottom has the least calcium content. And it just works that fast. So the next API I want to talk about is the Graph API. And that one I had to include in the demo because you use Gremlin to talk to graphs. Anyone here work with Gremlin at all? Anyone want to work with Gremlin because it's just cool to tell people you work with a Gremlin API? I don't know. Sounds kind of interesting. So what we'll do is we'll look at a Cosmos database, but this one's configured with a graph. And so instead of seeing collections here, I see graphs. And I can go into this flights graph. And what it'll do is it'll automatically recognize the API being a graph database, and it lets me use this Gremlin query language to pick out what I want. So I'm going to tell it to give me a vertex with a label of SEA for SeaTac Airport. And what this will do is it'll pull up the information for me. And then I've got some properties over here on the right side. You can see label airport. We've got this little graph that's actually visualizing the nodes for me. So I can pull that up. I'm not sure why I'm not scrolling successfully, but we'll, you can see kind of the edge of it, so that was exciting. And then what I can do here is I can actually tell it, give me all of the edges that come out of SeaTac. And that's going to give me a list of all the airports that have outgoing flights from SeaTac. Of course, instead of scrolling through all of them and looking at them individually, I can also do a count and get back that there's 90 or so of these edges coming out. Now, I can use the SDKs for Cosmos DB to project Gremlin queries. And so this is an example of code that's going to plot a course between two airports. And it says, get all the edges coming out of this one, go all the edges going into this one, and find the path between two endpoints. So that is this little demo app. I've got the Bing map control. And I came here from Atlanta. So I'm going to plot Atlanta to Seattle, click submit. And again, what it's doing is going out to the graph, asking it for edges coming out of Atlanta, for edges coming into Seattle, tracing paths between them, and optimizing those. And then if I do this trick of a clockwise mouse, it'll speed things up, and we get all of the different flight paths. And now the green one is the shortest distance, which is a direct flight from Atlanta to Seattle, which is my personal preference. Now, the last thing I want to show you, which is kind of cool with the graph database, is we also have this SQL API that lets us write SQL-like queries. So going back to the exact same graph database that I showed you, instead of using this Gremlin syntax, I'm going to do new SQL query. And you can see SQL syntax, select star from C. Let's just select top 5, execute query. And we'll get back actual documents that back these graphs. So we can see there's longitude, latitude, label, etc. So because this is ID, I can say where c.id equals SEA. And just using SQL syntax that I'm used to, I get back the one document that happens to have the Seattle airport in it. So that's using both the graph syntax as well as the SQL syntax over the same database because of the unique way it's stored behind the scenes. So hopefully what you got from this is a different way of looking at data and approach to databases. Hopefully you see that Azure Cosmos kind of has your back if you want to stand up a managed solution, especially if you've ever had to stand up a SQL cluster yourself or set up geo-replication. Probably seeing a checkbox in the portal is an exciting way to do that, right? The scale, speed, and security are all provided for you. It's ready to go for multiple languages. The SDKs are across the board. And this is the actual repo right here that you can get the example. I will pose with the slide later on after we transition. Be sure to fill out your session evaluations. Your feedback's important to us. And I am going to finish out right at 20 minutes. Thank you so much for your time this afternoon. Appreciate you all.